Good morning, chemistry. Here we go. Yesterday, you watched me perform 5 separate titrations in this lab, and hopefully you collected all the data. Today, let's talk about what needs to be, typed up in your lab report. Number 1 would be a title. Number 2, you got to make it up, but a couple sentences on a purpose. Number 3, then, is just for each area, say analysis of vinegar, break it all down, have a data table with all the data, which would be depending on the thing. Well, two things we know. All the sodium hydroxide concentration was always 0.25 molar. Always. That's the sodium hydroxide only. And in the last two with the base, the hydrochloric acid concentration is always 0.10 molar. Then, of course, masses, volumes of stuff measured out, volumes of sodium hydroxide base used, those kind of things. All that data should be in a data table for that section. And then the analysis questions. You don't have to write out the question, but you do have to number it and then follow through and show all the math where appropriate. Okay. So let's just kind of go through these a little bit. So you'll have your title, you'll have your purpose, you'll say analysis of vinegar, you will have all the data. What did we use? We used 10 milliliters of vinegar. We used 32 milliliters of 0.25 molar sodium hydroxide. Okay. So then the first thing is we've been kind of practicing is then analysis question 1, you have a balanced reaction between sodium hydroxide and acetic acid because acetic acid is the acid in vinegar. Okay. Then when you have that balanced equation, then find from the volumes and concentrations, get the molarity of the vinegar, the acetic acid. So that's just your NBMAVA equals, right? And plug that in, show the math, and go. Number 3, determine the molar mass of acetic acid. That's just add it up. Add up the molar mass. You've got the formula of acetic acid, add it up. And then 4 is knowing the molarity and the molarity formula, which is molarity is moles per liter, right? Then find the moles in the grams. So the first thing, you've calculated the molarity of the vinegar in number 2, the acetic acid. You know the volume that you used, it was 10 milliliters. You can then find the moles, right? Because moles is molarity times volume in liters. And then from moles, you can go to grams. Okay. And then it has you figuring out all vinegar, no matter where you buy it, says that it is 5% by mass. So here's what we say. If a liter is 1,000 grams, what is the percent? Well, you have your grams here. Divided by 1,000 times 100 gives you your percent. And then you can do a percent error with the 5% standard known value. Okay. That's the way most of them work. Then we did the blue vanish. And again, now you would have all that math, all that stuff, and then you would say analysis of vanish. You would have the vanish data table, the grams of it, the volume of water we dissolved it in, the volume of the base used, etc., the sodium hydroxide used. And then again, notice the questions are essentially the same. Write out a balanced equation. It's even given to you highlighted here in yellow because it's because of the type of acid that it is. So you just copy what's in yellow, including the negative signs and everything for the charges, whatever. And then calculating the molarity of the vanish is just doing the same thing, MAVA, MBVB type thing. Okay. And then since you know the molarity now and the volume, you can figure out how many moles there were, and then how many grams, same as you did above. When you are looking for the grams, use the whole formula, not the shortened acidic work up here in the equation. So use the sodium, the hydrogen, the sulfur, and the 4 oxygens for the molar mass, and then to get the grams, okay? And then you can take your mass you started with and the grams here, and you can figure out what percent, okay, was the acid, because again, from reading the material above, the acid should be about 62% of all the granules in there, and then there's 38% of fluff, filler stuff, inert materials that aren't part of the reaction, okay? And then here's the question that people stumble on. Although you have no reason to be in a chemistry, I could take this to anybody who never had a chemistry class and give them the background on it, and they would most likely have the ability to answer it, because it's really not a chemistry question. But it's really just saying in your sample, you got less than 62% most likely. I haven't done the math yet after my thing, but most likely your sample is going to be less than 62%, although the canister says 62%. Okay? So the question is why? All right, the unknown acid, that one goes a little bit differently because you have to make an assumption. So just use a molarity as moles per liter, and you have the molarity, the 0.25 mole molarity of the sodium hydroxide, because that's what it is all the time. And you have the volume that you used, which, just a quick reminder, we know how much water we mixed it with. Somewhere in there. Or not, sorry, not how much water. You know the molarity of the base, and you know the volume of the base from start to end. So the difference, so it's about 26 milliliters. So if you have volume and you have molarity, you can find the moles. Okay. Then you have to make an assumption, because it says how many moles of acid were used, but you don't know what the acid is to make that, to do the calculations, but you have to make an assumption. And the term monoprotic comes in there. And all monoprotic means is it has 1 H. Okay. So with sodium hydroxide having 1 OH, then you got a 1-to-1 ratio. So in theory, then, starting with the moles of the sodium hydroxide and the moles of the acid should be the same if it was a 1-to-1 ratio. That's the assumption you have to make. You have to make a guess at first. Okay. And then you look for the molar mass by taking the grams we used of the unknown acid, dividing by the moles, and you get grams per moles, and you get your molar mass. Then you have to make a choice. The unknown acid is one of these 4: sulfuric acid, maleic acid, citric acid, or oxalic acid. You will have to figure out their formulas and their molar masses and compare to your answer. That's how you find the unknown. That's what question number 4 is. The acid is known as blah, 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 blah. Now, you say to yourself, well, I did this and none of these really match what I got for an answer in 3. That's because we assumed it was monoprotic. Okay. But you know from balancing equations on the other stuff and from our titration practice that if it has more than 1 H for just 1 OH, that's going to change the ratio. You know, if it's diprotic, it's a 2-to-1 ratio. If it's triprotic, it's 3-to-1. So you'll have to do a little looking at it. If you don't like anything you see, if when you add these all up, you don't see it quite matching what you did here, then you can't assume it's monoprotic. Then it might be twice the number of moles, 3. Anyhow, I'll let you figure that one out. But once you make your choice, then you do the percent error. Okay. And for the theoretical value is always the one you add up here. Okay. Then we did a couple of bases, and as I showed you in the lab, bases are different than acids because you have to put an acid You have to neutralize with an acid 2 different things. So that's why the questions go differently. Number 1, how many moles of the acid were used? That's just molarity is moles per liter. You know the molarity of the acid, it was always 0.10. And you know the volume of the acid that we put in there, because I think I told you. In fact, I know I told you in this first one. In fact, it's even written in the procedure. We use 50 milliliters. Okay. So then you can find the moles there. For the moles of the sodium hydroxide, again, you know that the sodium hydroxide in the burette tube is 0.25 molar, and you know the volume you use from the start and the end point. Okay. We used somewhere in there, like 8.5 milliliters. Like we started at 1 and ended at 9.5. So then you can find the moles of the base. Now, in theory, in a 1-to-1 ratio, these should be the exact same number, but they won't be because you also use the acid to neutralize the rolanes. So how do I know the moles of rolanes? What's the difference between the first two? If the acid knocked out both sodium hydroxide and rolanes, then finding the acid moles and subtracting the sodium hydroxide moles will find you the moles of rolanes. Okay. All right. So, and how many milliliters of the acid did the rolanes neutralize? Once you know the moles that it neutralized, again in a 1-to-1 ratio, now that you know the moles and you know the volume of the acid you used, you can figure out how many milliliters of the acid was actually used for the rolanes. Okay. And then there's another question there that they used to say in the commercial. Okay. Analysis of the unknown base solution is almost exactly the same as what you see here. Your first 2 steps are going to be how many moles of hydrochloric acid were used. So again, we know the volume from the procedure. We use 40 milliliters, and the hydrochloric acid. Okay, so you know the volume and you know the molarity, so you can find the moles. Again, here for the sodium hydroxide, you did the titration. Okay, so you know that you had 0.25 molar sodium hydroxide, and again, I think we used 8.5 on both of them. So that can give you the moles of sodium hydroxide. The difference will be your unknown base. Okay. So the first 3 questions are the same down here. Then it differs because it just wants to know the, you want to calculate the molarity. So once you found the acid moles and the sodium hydroxide moles and you subtract, now you have the moles of your unknown base. You can divide by the volume of unknown base, which was the 10 milliliters, and find out the concentration. And then it says your instructor will provide the actual molarity. It was actually 0.25 molar, unknown base. So then you can do a percent error between what you find for it and what the actual is. So you have all those with you have a title, you have a purpose, just a couple sentences overall, what were we doing in the lab? You have the title Vantage section with the data table, the analysis, and the math shown in that, just numbered, don't have to rewrite the questions. Same for the next one, bam. Same thing for the Vanish, same thing for the unknown acid, same thing for the Rolade, same thing for the unknown base, then you write a conclusion at the end, following what we've always done in class. What was your purpose? Did you achieve that purpose? Provide some data to back it up. Where could errors have come in as you, well, I know I was doing it, so that's often harder to find. And then the wrap-up statement. There you go. This isn't going to be due till next week. I haven't chosen the exact date. It's going to be due probably Tuesday, so you have the weekend to work on these things. And then you kind of have Monday and Tuesday to drop into an office hour if you need me to help you with any of the math. So there you go. That was a titration lab. That's the analysis. Again, if you have any questions, just drop into any one of the 3 office hours and ask. We'll talk to you later. Have a great day.